All right. Chapter 3, page 45. A Morse code of action and rest. You will remember from the previous chapter that our physical bodies and all matter is made up of interacting electromagnetic fields vibrating at tremendous frequencies. At room temperature, an atom will vibrate at a rate of 10 to the 15th hertz. That means 1 followed by 15 zeros. The nucleus of an atom will vibrate at about 10 to the 22nd hertz. These are almost inconceivably fast rates. In the process of inventing live systems, nature had to come up with sensory organs that will allow these living things to interact with their environment. It had to use available building blocks that, as we have seen, are very jittery. In order to communicate with a slow mind, nature has largely given up the tremendous information handling capacity that is inherent in matter itself. If an atom is vibrating at million billion times a second, 10 to the 15 hertz, that means that it occupies two distinct states so many times a second. In other words, it can say, for instance, yes, no, so many times a second. Now, if we can utilize all this capability by superimposing a modulation on this fast behavior that would in turn alter this behavior either in amplitude or frequency, we would have a very fast communication device. This speed is utilized in molecular interactions, but our sense organs are hopelessly slow to handle directly the onslaught of this much information. Well, after a lot of experimentation, nature came up with a reasonable solution. It has bound atoms into molecules which have much lower vibratory rates because of their much larger mass. Out of these molecules, which still vibrate at gigahertz, 10 to the 9th hertz rates, it has made live cells, which are the building blocks of all organisms. Then came the specialized nerve cells, or neurons. A rudimentary nervous system resulted that translated sensory input into a slow Morse code fashion of action and rest. It was a process of gradually stepping down the higher vibratory rates of the atoms to the reasonable vibratory rates of the molecules to the acceptable frequency response of the cells, which is in the 10 to the 3rd hertz range for an assembled live cell. In other words, a cell will be able to respond to stimuli at that rate. It is very possible that sensations that do not come directly through the sense organs, such as general malaise or feelings of anxiety and doom, restlessness, and elation, may come through a different kind of mechanism. These sensations might be evoked by the fluctuation of the different fields in which we are immersed and by the rate of vibration of the molecular structures in the brain or the endocrine glands. In the last chapter, we cited the effect of the moon on emotions. Changes in the electrostatic field may also cause such effects as lassitude or elation. Sensory organs. Our sensory system, as you may remember from biology classes, is made up of a system of sensing nerve cells located at the proper places in our sense organs. The cells are connected by long nerve filaments that join into bundles with neighboring filaments. These eventually lead to the spine to form the spinal cord, then lead up into the different areas of the brain. The physiological studies show that when a sensory nerve cell is not stimulated, the output of that cell will consist of sparse and unevenly spaced electrical pulses, or spikes as they are called, figure 20. However, if we apply pressure or any other stimulus to that nerve cell, its output will become very lively. With each stimulus, the cell will fire off salvos of closely spaced spikes. Their rate per unit time will depend on the strength of the stimulus, figure 21. Our whole sensory system operates this way, whether it is optical input coming through the eyes, acoustical through the ears, or tactile through the skin. And the end result is a series of spikes conducted to the appropriate area in the brain. In short, our senses translate the surrounding reality to us into a Morse code language of action and rest. Action comes when the neuron fires its spike, and rest comes as the cell is regenerating and readying itself for the next firing. Out of this action and rest code, our brain constructs for us, for example, the form of a rose, its texture, its color, and smell. In other words, its rosiness, or it will construct for us a faint image of distant galaxies coming in through the eyepiece of a telescope. Let us see what other systems operate on an action and rest basis. The simplest one appears to be the pendulum. We are all familiar with the relaxed pace of the grandfather clock pendulum slowly moving to and fro. It is behaving in what is called by physicists simple harmonic motion. Let us take a weight on a string and set it in motion, figure 22, so that it describes a circle which we shall call trajectory A. The circle is connecting to points 1 and 2 in the plane in which the pendulum is moving. Now let us start confining the movement of the pendulum by forcing it to move between two parallel plates, which are moved closer and closer to each other so that its orbit will become flattened into an ellipse. We shall call this trajectory B. If we confine the orbit of the pendulum even more by moving the plates closer to each other, we get a very elongated elliptical orbit, C. And if we continue to restrict the freedom of this pendulum, we finally force it to move in a straight line, which is connecting points 1 and 2. What we did to the unfortunate pendulum was to limit its freedom and force it to move along one plane only. This back and forth motion between 2 points is the equivalent of projecting the movement of the pendulum onto a flat screen facing the observer's eye. We have converted circular motion into a reciprocating motion by taking away some of the freedom of the pendulum. However, we did not change the time required for each to and fro movement. It is still keeping the correct time. All we did was to convert a simple circular periodic motion into a linear one, which is still a simple and harmonic motion originally generated by a circular motion. In this way, we can convert all uniform circular motion, whether it is that of an electron or of a planet, into a simple harmonic motion. The only limitations is that it has to be viewed always from the same plane and the same angle if two observers are to agree on the timing and position of the pendulum in each instance. Thus, subjectivity enters the picture. The two extreme points of the pendulum at which there is no apparent motion are different for different observers unless the event is observed from the same angle. If the observer looks along the direction of the back and forth motion of the pendulum as it moves in a straight line between the plates, he will see no motion at all. He may see the pendulum slightly closer and slightly farther from himself, but no sideways motion will be visible. He will be observing the 2 points of rest. Hierarchies of motion. In Chapter 2, we describe the micro-realities as being made up of interacting energy fields that can be represented as particles. These particles have many properties. They have a charge, a spin, magnetic moment, and strangeness, and in the last few years, color and charm have entered the picture. Let us visualize an atom made up of a nucleus and electron shells. We find the electrons orbiting rapidly about the nucleus while at the same time rotating about their own axis. If we look now at an aggregate of atoms in a crystal, we find that they vibrate about their fixed position in the lattice of this crystal. Thus, the micro level of nature is represented by 2 kinds of motion, a circular spin-like motion and a reciprocating motion due to vibration, each about a relatively fixed point. Let us go one step up in the hierarchy of structures in nature, for example, to that of large molecules. These molecules confine the atoms to relatively fixed positions, and any free branches of such molecules will tend to exhibit pendulum-like movements and rotation. The free segments of these long molecules will also vibrate in and out, resembling the movement of a stretched vibrating string. The rate of these movements is much, much slower than the rate of orbiting of the electron about the nucleus. If we look at simple living structures such as protozoa or plankton, we find only one kind of motion, the reciprocating or to and fro motion of the pendulum or spring. If we watch simple single-celled animals under a microscope, we find that their movements are jerky and that they derive their movements by beating their flagellae back and forth rapidly. They may rotate about their axis, but that is caused by the reciprocating action of their little legs. As the organism becomes more complex and a rudimentary heart develops, we find a back and forth pulsation of the primitive blood fluid that causes, in turn, a back and forth recoil of the body. Throughout the animal kingdom, from plankton to elephant to humans, we find that reciprocating motion prevails. There is almost no spin in the living structures. We are confined to a pendulum-like, or if you wish, oscillating behavior. As we go up the hierarchy of sizes and to heavenly bodies, orbiting and spinning reappear. We know that all planets rotate about their axis while at the same time they orbit around their respective stars. We know that galaxies rotate, as do galactic clusters, and so on. In short, we find that one of the unique characteristics of live creatures is their reciprocating motion. But is nature so inept that it could not invent a wheel, which our very primitive ancestors easily managed to do? How come? Or is there more to it than meets the eye?